Yeah, so I was just having a quick chat to Steve about his company and his FHIR server and his use case. Um, so you have a FHIR server that's based on Cassandra as a backend. Does it have any sort of bulk data interface?
We're adding that now, both bulk import and bulk export, and we want to enhance the export to support Parquet. But really, what we want to do is enhance it to use view definitions and then have those export to Parquet.
Okay. So you want a bulk export API where you can say, give it to me using this view definition, and it'll just give you the result rather than the full set of FHIR data.
Yeah.
Okay, that's great. That's kind of a bit of validation of it. One of the ideas that we were talking about in dev days, because I think there's a few models here, right? Like you can push that sort of responsibility for transforming the data onto the sort of source, or you can do it at the client, or you can even potentially have some sort of halfway house where you sort of use a view definition to sort of trim down the data or subset the data and then do the full transformation downstream. But we've sort of been talking about possible proposals to add things to the bulk data access IG to make it SQL on FHIR aware, if you like, and add maybe one or two things there to enable this. So yeah, that's interesting.
Yeah, that's where I would lean as well. I think that makes that makes the most sense, knowing the complexity involved in all of this.
And then once you have your SQL on FHIR view result as Parquet, what would your customers typically do with it?
They would load that. Once you're in Parquet, then the world is open to a whole universe of different tools, whatever they would like. Name your favorite analytics tool. They want to start with Parquet files.
Okay, cool. Hey, yeah, Bashir.
Hi. Yeah, I was just listening. I was curious that. So just making sure you know about the Parquet format or the Parquet schema that we have been talking about as well, which is trying to have a lossless, almost lossless transformation of FHIR resources to a Parquet schema. And then the idea is that you will have that in Parquet format. Then you can use Parquet tools on top of it, or you can apply view definitions as like virtual views on top of those Parquet.
Okay, so I've caught bits and parts of that conversation, but not the full breadth of it. I do wonder how even in Parquet you're going to get around some of the nuances of FHIR, like some of these, like you see it in questionnaire where you have, or questionnaire item, I guess, where you have self-referential relationships,
recursive, basically. Right.
recursive relationships. There's some other wrinkles as well, but have you guys thought through all of that, or?
So
yeah, that's actually, that's exactly basically what I don't know, John, how much did you, with Chandra, how much that conversation went forward in dev days? Because each of us do it, I think, a little bit differently.
So maybe it's time to sort of share what I whipped up. So we're actually a few sort of iterations into this problem. So we and Ryan Brush and Bashir and a few others have actually had a different go at different types of parquet renderings. And yeah, like on first glance, there is that problem, as you say, Steve, that, you know, in FHIR there is recursion. So you can have like arbitrarily nested structures, particularly in things like questionnaires and that sort of thing. It's also just really large as a schema. So if you encode every possible type, it's just a massive schema. And there's also extensions. There's also primitive extensions. There's a lot of sort of different challenges there to having like one schema to rule them all, I suppose.
Right.
But the latest idea that we've been working on is sort of this idea where you have a schema that can represent everything that is theoretically infinite, right? It's very close to what the JSON format is, if not exactly what the JSON format is. However, an instantiation of it doesn't have to have all the fields. So the fields are optional, and the idea is that it conforms to the schema in terms of the names of the columns and the location of them and the data types, but it doesn't have all the fields. And the idea is that if you need to, you can merge these schemas like for two different data sets because they conform to this spec, they won't stomp on each other. And implementations have like this sort of schema merging, schema evolution type feature where if there is a column in there, and this is all still a bit untested because there are some aspects of this that we need to see if they actually work in practice. But that's kind of the idea at the moment. So I came up with a bit of a draft spec that embodies this idea, I think. So it really is just describing, it doesn't describe the actual schema for a particular resource. It just describes a method for deriving the schema from a resource definition. So, you know, for each of the primitive elements in the schema, use the name of the element and use this data type for it. And you can sort of just see a little bit of an example there. So if you had like a patient resource with only the fields ID and birth date in it, theoretically you could just have a really small parquet schema with 3 fields in it. But then if I had another patient table which had ID, birth date, and gender, I could potentially merge them both into a table with all those fields, right? So that's kind of the idea, but still experimental at this stage. And then you've got to have ways of doing repeating elements, choice types, complex elements. But this is all very much mirrors the way these things are done in JSON as well, right? And the advantage of that is that you can use it with like the schema inference features of existing implementations. So for example, like DuckDB or Spark, you can feed it a JSON data set and it will infer the schema that can accommodate that data set. And then you can save that to Parquet, and that Parquet would look very similar to this, if not be compatible with this. Primitive extensions, again, exactly the same as the way it's done in JSON. And then like the last part here is sort of my attempt to describe like a way of having like optional annotations within the data set. So the sort of idea is that you would have the data as original as possible. So if we go back to the data types here, pretty much everything is a string except for integers and booleans. And the reason for that is that you want to have like a lossless representation of the data. So, you know, even things like decimals, you want to preserve the scale of the decimal as to what it was in the original data. Things like dates, you want to preserve the way they were represented. But you still want like, that might not be the best representation for querying it, you know. So for querying it, you might want to get it into a native date type, or you might want to convert it into a numeric decimal. So the idea is that we have this kind of lossless representation that's really, really close to like the original, like JSON or whatever. And then we have sort of a concept of annotations and how you can represent them so that you can tell what's an annotation and what's not. And maybe some standard ones so that that cover like really common things. So a couple here are like date ranges. So, you know, if you have a birth date that's like a day, or even you don't even know the full date, for example, which can be common in some parts of the world, you can have like these start and end annotations, which are effectively like the instant at which that range starts and the instant at when it ends. So you can do stuff like everybody who was born since this particular time, and instead of using the original birth date that was in the data, you can use this, you know, birth date start instant in a native, you know, timestamp thing, and that can be sort of an easier way to query. Decimals is another one. So like, you know, we want to preserve the exact way that the decimal was represented in the first place, so that we can, because another goal of this is, you know, we want to be able to produce FHIR back out of it as well. So we want to bring FHIR into the Parquet format and bring it out, and theoretically it's the same, right? And we can't really necessarily do that if we you know, change the way that we represent. So decimals is another one. And the third one that I've got in here so far is quantity unit canonicalization, which is something that we do in Pathling, which is where you take quantities that have a UCOM unit and you change it to the canonical units. So like an example of that is like you have temperature observations, and half of them are in Celsius and half of them are in Fahrenheit. And you want to do a query that says, you know, everything above 30 degrees Celsius. Well, if you have an annotation in your data set that sort of has a canonicalized form of that, which is in Kelvin, and then you canonicalize your query as well, then you can do those sorts of things as well. And you can do this when you load the data into the table, so that you have the original and you also have this other annotation, if you like, so that you can optionally use it if it makes sense for you in the query. So this is still super early, and it was written with like a lot of jet lag on board, but I'm hoping to sort of get a bit of a little bit of a proof of concept implementation going on this. But I'll post the link anyway, and you guys can have a look.
Yeah, this is great. Thanks, John. I mean, just to the point for what Steve was talking about, like for recursive, for example, usually in any way that we do the schema generation, we basically break recursion at some point. So we say that, you know, okay, I want 2 levels deep, or you may say for this particular, you know, FHIR path or path, basically I want, you know, deeper, like, you know, 5 levels deep or something like that.
Or you change around the schema completely for that. I mean, what we've had to do, so to answer Carl's question to the chat, Carl, we have an implementation of FHIR that rides on top of the Apache Cassandra database, and Cassandra is similar. We've had to do some weird things with how we represent the data, FHIR, especially for those recursive types. And what we've had to do is, when we have a list of them, and what we do is we simply break the sort of the pure form of the data model, and then provide an index into a whole separate table where you represent that recursion. So makes it clunky for analytic purposes because you got to do some more joins, but it works. And it nicely, you can get the data out, you can get the data in. I was interested in what you just showed, but on Parquet. So really, what you're saying is you're not going to have a complete data model, a complete Parquet data model for all of FHIR. You would it would be generated based on the attributes that are used.
That's right. Like there is a full Parquet representation of FHIR, but it's actually theoretically infinite. And you generate something that conforms with it. So for example, the way that we're implementing it is to just do JSON schema inference on the data set and then do some minor modifications to that and annotations to that. So like, for example, the JSON schema inference for Spark is actually very close to this. And you just really coerce a couple of types into what you need and annotate it with some additional things that might be useful for querying, and you're done. And then when you go to combine it with something that's been produced with a sort of conformant method, I suppose it just works as the idea. But like I say, still experimenting with this, and it requires a couple of things. It requires that sort of schema of evolution thing. For the merging, it requires you to be able to evolve the schema both at the column and the struct level, which is theoretically possible, I think, but I'm still making sure that that works in all cases.
And that piece, is that specific to the Parquet standard, or is that specific to a tool that is using Parquet?
The merging of the schemas, it's not really specific to Parquet, but it is something that's I think relatively easy to do with Parquet. Am I getting that right? But FHIR, like yeah, so it's something that you can do with both Spark and DuckDB, I believe, but I'm still experimenting.
Yeah.
Yeah, I'll add also that this is an interesting approach. I thought, John, the way that we do it is that we actually, we get the configuration in advance. So basically, you say, I want one recursion level, and then we generate like a fixed schema without having any data. And then basically, if you have like a FHIR resource that has like, 2 recursion levels, then that data is dropped. Now, there are advantages and disadvantages to this. Like, obviously the disadvantage is that, you may lose data because it's lossy, basically, your projection, and always it would be lossy. I think the benefit is that you can write SQL, let's say, against a fixed schema, and then you can expect that to always work. Because I think, John, correct me if I'm wrong, but I think, let's say if I write SQL and then it's referencing a patient field that is not in the mini schema that you have created based on your data, then the SQL will fail. But I guess in our thinking was that, you know, you will have that SQL works because, you know, it complies with that schema, but then you don't have data in those fields, basically.
Yeah, you're absolutely right. Like, your SQL has to either know what's going to be there or be tolerant to what's not there if the fields are not there. So that might be okay for, so that I think that's probably okay for something like a SQL on FHIR view runner, which is general and can implement ways of doing that, right? So you can say, if there's no field, just return an empty collection, for example. But it's probably harder, or yeah, if you've just got some piece of SQL that has some assumptions about what's in the schema. So yeah, that's something to think about. The other thing is, one of the reasons that we're motivated to do this as well is also performance, because the size and complexity of the schema seems to have a very close relationship to overall query performance. So it's really attractive to us to sort of have the option of having a schema that doesn't necessarily have everything in it, if your data set doesn't need that, right? So we've thought about a few approaches to this in the past, you know, like profile driven and that sort of stuff. And I think that this spec actually doesn't preclude either way. So you could have a comprehensive schema that complies to this spec, or you could have a trimmed down schema that complies to this spec. So maybe it's like horses for courses. You know, maybe in some cases you want to fit this schema to your data and ship that somewhere, or do some querying on it with an engine that is happy with that. Or in some cases you want like a really comprehensive schema, like you're saying, FHIR, where you basically fill out every field, you know, with some caveats, you know, like nesting level and that sort of thing. And maybe that makes more sense for other environments. So I don't know, that's just my initial thoughts on it.
Yeah, if this works, you wouldn't necessarily need view definitions, would you?
Well, you still, so the value of the view definition is that it's still really complex to query this stuff, right? And query it in the right way. You know, you have to write a lot of sort of SQL to achieve the same sort of thing that you can achieve in a view definition. And, you know, deal with data types and whatever else, you know. So I think that there's still a lot of value in having like a generic tool that can pluck sort of columns out of this thing. But I guess the reason we're thinking about this is, you know, as a potential alternate way of shipping bulk data around, which is closer to the format that is amenable to query. So if we could get it in this format, like if you want to convert it to something else, it's really fast and pretty trivial, because you can do, as you say, most engines support Parquet, and we can just do a SQL transformation of this to whatever you want to be the base for your querying, rather than bulk data where we have to serialize everything in and do that sort of transformation all the way from JSON. So I think it has utility for a few things, but yeah, that's kind of where we're at with that.
Yeah, I think the view definition, I mean, our thinking has been also that the views will become the API for downstream users. So basically you write your queries, like, you know, the downstream data scientists or, you know, whoever building dashboards or whatever, they write their SQL against the view, like the flat view, which is much easier to work with. And then it's the responsibility of the, I don't know, the data engineers or whatever, to actually do the transformation from view definition to whatever format they are using on the backend. So, like, I mean, we started this conversation when you said you are thinking of doing view definition on the FHIR server, basically, and then generate those like flat views, maybe as Parquet files. And what I was thinking, not saying that one is better than the other one. One approach that we have been considering is that we work with like a rich format, like a rich schema that can retain everything that is in FHIR in Parquet format. And then the translation from view definition is into like a virtual view. So basically, like, I mean, you are still, the downstream user sees the view as the API, like the flat view, but under the hood, it's basically just a virtual view on top of the lossless Parquet program.
Okay.
Yeah.
So you'd be the transformation for view definitions, the transformations would not be, there's two ways to implement that. One is however it's represented inside of your database, or what you're proposing here is it's a transformation of these Parquet files, really.
Yeah, or in some sense, basically SQL. So like SQL gymnastic. So
Yeah.
the view definition implementation becomes like SQL. And I should emphasize that we don't have it fully implemented. This is something that we are thinking is a good idea when we do it. With Parquet and Spark, is a good idea to do it this way. Like Ryan is on the call. I mean, I think he has done something similar with BigQuery, for example, and we are trying to basically replicate something similar for Parquet and Spark. By the way, I didn't want to like create like a side topic. It was Parquet was mentioned on the agenda, so I think we are still within the agenda. But also, I think there are other things that people want to discuss. So hopefully, I didn't sidetrack the conversation too much.
Well, Arjun's not here, so we're here and we get to make the agenda. We're off the leash, right? So is there anything else anybody wants to comment on that topic before we potentially move on?
Since we discussed Parquet, and because I was not available during dev days, so did we come up with any? And I haven't caught up with Chandra yet. Did we come up with like a plan, like for having, like to continue the discussion here, or having a separate subgroup, or?
I think the plan was to have another Parquet themed meeting soon. So whenever it suits you, Bashir, and we'll possibly put out another doodle poll just to make sure we get everybody who's got an interest coming along. We can pick one of the weekly meetings and just focus on this subject sometime soon.
I appreciate that. Let me introduce myself. I'm Shane Peterson with One Up Health, and we've certainly had some experience with Parquet. I guess maybe don't need to get into all of the details on that here and now, since it's a little bit of a sidetrack. But I'm probably more opposed to Parquet usage, and I can share some of our experiences with it and some of the issues we've encountered with that at the, I guess, right time. But yeah.
Okay, great. That'd be really valuable.
Yeah. So are we coming up with a document to kind of track some of the pros and cons, issues people have faced with it, or do we want to just keep this sort of verbal in a meeting?
So we've had many discussions about this. They're all recorded and on YouTube, and we also try to take notes and put them on the analytics on FHIR thread on Zulip. The notes might be a bit sparse today. So that's kind of where we're at. I put a link in the chat I've just been playing around with some ideas since dev days as well. So I think that's kind of the sum total of what we take into this meeting. We've also got existing implementations. So we've got the Pathling implementation, we've got the Google Open Health Stack implementation, we've got, you know, we've got the original Bunsen implementation, which are all different takes on like schema, but those three are all fairly similar. The sort of Google protocol buffers is not Parquet, but it's sort of very similar sort of way of representing it in a schema. So we've got a lot of sort of existing work, and we've also got a fair bit of experience as well around all the you know, gotchas and all the rest of it. But that would be awesome if you could come along and share your experiences. That would be super
Yeah, absolutely.
helpful.
Yeah. Do we have a link to where this is being captured, or?
Yeah, yep, I will share that in the chat, no problem.
Okay, perfect.
Yeah,
And
so
also, yeah. Mhm.
I was just going to say that this is slightly tangential to the SQL and FHIR view runner part. So we've got these kind of three layers, like analytics layer, the view layer, and the data layer. And our views, which is the main subject of what we talk about in this meeting, is actually agnostic of the underlying data format. So this is in the data layer, but it is quite it's a key enabler of sort of the deployment and practicality, I think, of SQL and FHIR more generally, because if we can agree on a format to pass data around as, and if we can, you know, perhaps use this as a data layer within some of the SQL and FHIR implementations, I think that helps. That helps what we're trying to do. So that's kind of why we're talking about it.
Yeah, and also the schemas. I mean, there are a couple of, I guess, documents going around for documenting the schema, which is, I mean, it's not necessarily part of this meeting discussion, but, you know, I think each of these groups have their own like documentation of the schema as well. So I think the main thing that we should try to do is to bring all of these experience and everything that John is talking about and all of these documents for various ways of creating this schema together and try to consolidate that and come up with like one Parquet schema. That, I mean, in my opinion, that would be very, very good if we can come up with something like that. But yeah.
Okay. So we have a little bit over 20 minutes left. So there's a few things that we could talk about. I know that both Carl and Fatima had expressed interest in talking about stuff. So depending on whether you want to do that now or at another meeting, we can do that. Otherwise, we can talk a bit about where we're up to with the spec, but I think that that's probably pretty boring, and we can probably do it out of band. I think this is more valuable when people drop in and share what they're doing, share their use cases, and have a bit of a Q&A around that. And I know, Carl, that we've been talking a little bit about your stuff and OMOP and some of the challenges with doing that and how that relates to the design of the view definition and all the rest of it.
Yeah, I mean, I could talk quickly and just sort of plug what I've been working on. I think I might want to come back for a later meeting or a separate meeting and just sort of go through in more technical detail what I built and how it works. But essentially what I have is I wanted to write a demo that shows how you convert FHIR into OMOP, and I use the bulk data export files, the NDJSON as input. And I'm using JQ to quickly pull apart the pieces of information and produce tab separated values that I can load into an OMOP CDM database. And it's all, you know, toy level. I'm using SQLite. I'm only using Bash and JQ. And, you know, I've gotten through 5 or 6 of the major mappings. I'm working on observations right now. But it's fast. It does like 20,000 rows or resources per second per core. And it's totally parallelizable. So, you know, you can throw significant machinery at this and expect to see gains. But I'm also like figuring out how to best do the mappings using R4 into OMOP 5.4. And, you know, there's a fair bit of head scratching and doc reading for every single transformation. And what I encountered that led to discussion in Zulip is for practitioners, the OMOP CDM asks for the provider table, and the provider table has columns for things like the provider specialty. And there's one, you know, there's one specialty per provider. You can't have more than one in their schema. And I realized that the specialty data is encoded in the practitioner role resource, not in practitioner. And so what I've devised is, as I pass through the NDJSON, as I'm going through the practitioners, I'm emitting partial OMOP records, so fragments. And then when I pass through practitioner role, I produce the missing pieces. So they're joined on provider ID or practitioner ID. And then when I've generated all these fragments, I just do a simple like coalesce merge step where I scan through everything, anything bound for the provider table. I sort by provider ID, and then I coalesce all the nulls into one row, and then that gets inserted. So that's how I've been solving it. I'm not sure how or if this is even a problem for the view definition, but in order to create a complete provider record, you do need to get data from both of those resources. But anyways, I'll drop a link in the chat to the demo I've built and the tool that goes with it. And I'd love to get extra input on what I've done and get some people playing with it.
Yeah, that's exactly the way that I envisioned it would be solved with view definitions, actually, is to, because one of the design choices we made with the view definition was to make it single resource per view. And the reason for that is that it gets very complicated if you don't do that, and you have to start sort of reinventing generic query capability into the view DSL, which is not what we wanted to do. It was kind of a non-goal to sort of reinvent generic tools like SQL, and joins and that sort of stuff. We wanted a tool that could handle the FHIR specific part of the problem, and as early as possible after you solve that bit, hand it off to the generic tooling, which already has the ability to do this sort of stuff. So yeah, in the case of what you're talking about, Carl, I guess there's a couple of scenarios. You could have, you know, like a table with some columns that are derived from one resource and some from another, in which case that's a join, right? And another scenario is you have a table that has some rows that are from one resource and some from another, in which case it's like a union, right? But in both of those cases, I feel like the way to do this in terms of SQL and FHIR views is to have multiple views, and you've got full control over what the sort of output schema of those views are. So if you are intending on unioning the results of two different views, you have the ability to make sure that those views have the same columns with the same types so that they're unionable, I guess. And we've also talked about like operations to sort of infer the schema of a view without necessarily executing it and all the rest of it, so that you can make sure that you can accommodate these sort of things in downstream processes. But
So I think this is a little bit different than a union though, right? Because I'm taking, you know, the left-hand side of the table and the right-hand side of the table and squashing them together with something like a coalesce.
so tell us a bit more about the coalesce part. What needs to be coalesced?
So essentially, like, just think about the SQL coalesce function. You know, you give it multiple inputs, and the first time it sees something that's not null, keeps it and ignores everything else. So I'm taking the union of, you know, the two different rows for any given provider, and for every column I'm coalescing all the different values, and that's the row that gets inserted into OMOP. So
yeah, so did we land on so you got a practitioner and a practitioner role, right? And is this a one-to-one, a one-to-many, a
it's a
many-to-many?
one-to-many, or it's a one-to-one or none. And then within the practitioner role, you can have multiple roles defined. So there is a little bit extra complexity there, but the relationship between the two resources is one-to-one or none.
So can I do something like a view on practitioner and a view on practitioner role and a join
I
to
think so.
create just another table with columns from the first view and columns from the second view?
Mhm. I think so. And I guess I'm working with NDJSON as my source. I'm not working with the backend database of a FHIR server, so I can't do, you know, my own SQL views of, you know, the running content. I've just got a big bundle of files, and maybe that's a, you know, extra complexity that isn't realistic towards implementers, but
Yeah, no, I think this is still really informative, because we've talked a lot about OMOP being sort of a big, hairy sort of transformation problem that will help us sort of test out the any limitations in our design. But yeah, and I've got a project to do something similar actually, but I haven't quite got into it yet. But yeah, keep feeding us the learnings from that. I think
yeah. There's one other thing that's maybe worth mentioning now is when OMOP defines their tables, they have criteria for inclusion in their tables. So like visits, if an encounter is tagged with a concept code that is of the domain visit, it can be included, its data can be included in the visit table. But you know, if you look through all the encounter resources, maybe a small fraction of your data will be actual visit encounters. There may be other locations that will feed the visit table ultimately. So you might have multiple different resource types that you have to use to populate the visit table ultimately. But that feels like a different problem than, you know, the practitioner role, where you're actually combining two resources into one row. In this other one, you know, you may be producing complete rows for a destination table that are coming from multiple different resources.
yeah, so to me that's more like the union case, right?
Yeah.
So you have like
Right.
a view that has a where filter on it with a particular code that comes from encounters or whatever. And then you have another view that is the view of some other type of encounter. But as long as they're all sort of
Complete.
designed to fit into the OMOP table, we should just be able to union the results of them together, right?
Yeah.
And I think like a couple of nice things about that approach include one is having those sort of treating views as sort of that intermediate state of just flattening FHIR resources is, well, not only easier to implement as we've described, but also a lot easier to debug and troubleshoot. Like you kind of see, hey, for each FHIR resource, this is exactly what I'm getting from it. And then your layer on top of that, whether it's whatever your favorite database or ETL or transformation tool is like you have a fairly clean starting point of like these flattened views for resources that you can join your union together as needed. And hopefully that logic is a lot simpler, one, because it's starting from those flat tables rather than the complexity of FHIR resources. And then two, the SQL-based transformation would be a heck of a lot simpler because you don't have to deal with all the lateral view, explode, and nests and all that sort of thing there. So that's a couple of reasons behind it. So hopefully this is like a trade-off that seems reasonable to folks, just because as John I think outlined, like the challenge of like trying to do this within the view definitions or the runner themselves, it would be pretty daunting just by the nature of their structures.
Yeah, one question I have for you, Carl, is like, have you got a feel for like the use case specificity of the transformation? Because like, a lot of people are working on this FHIR to OMOP. Is it possible to have some sort of generic transform? Are there decisions you have to make along the way in how you get that data from FHIR, where you put it into OMOP, that are very sort of specific to the particular use case that you're working on and difficult to generalize?
Yeah, the OMOP documentation has a lot of guidance for how you decide what gets mapped where, and in some of that there's even some explicit, you're going to have to use your judgment on what you put in this for this and like visit detail is a good example of that. There's visit occurrence, and then there's visit detail, where you can put a lot of the extra information that happened in a visit inside that. And I think there's a lot more loosey-goosiness and interpretation there. But yeah, there's a lot of interpretation, and I'm working with one data set for now, which is Cynthia generated. When I start looking at actual Mayo Clinic FHIR resources, it's probably going to be a lot more complexity. So I don't think there's a general FHIR to OMOP solution, but I think that building up the tools to make it easier is important.
Yeah. So, and what those tools look like and how you sort of, tell them or configure them with your particular sort of choices for the use case is I think a tricky area. So I guess there's kind of one thing is to like, can we do this in a reasonable way with SQL and 5-year definitions? And then there's, is it feasible to extract parts of this problem out to general components to sort of reduce the amount of work you have to do, or at least sort of impose reasonable patterns on it, I guess.
Yeah, all the work I'm doing is out in the open, so I'm happy to provide updates.
Yeah, thanks so much for that. That's really valuable. Okay. Did anybody else have any questions for Carl or any more items on this topic around OMOP transformation? Okay. Well, I think we might just so just quickly before we finish up, on the spec, I've just been doing a bit of work to tidy up the last few issues that are there in the spec, and that's all going well, but just a reminder that we've got a milestone in GitHub with some issues there. We've also got a couple of outstanding pull requests, one on column ordering and one on low boundary, high boundary implementation. I'm currently working on the column ordering one, and that's getting close, but we do have this outstanding one of how we support low boundary, high boundary that probably needs somebody to review and progress as soon as we can. And there are also a few tickets outstanding in the milestone, and there's also a bit of editorial work to do. So just taking a look at the spec, and if you think it needs any more polish from an editorial perspective like that, it'll be very appreciated. But other than that, I think we might leave it there for today. For the next meeting, yeah, just let us know if you'd like 10 minutes or 15 minutes to share what you're working on, and we'll carve that out. And we'll also have we'll also put out a doodle poll and figure out when we're just going to have a focused Parquet session. So just yep, get onto analytics on FHIR channel on Zulip if you're not already on it. That's where we sort of post all our updates and what we're doing and all the rest of it. So yeah, other than that, unless there's any sort of further comments, we might wrap it up.
Good to me.
Okay.
So, thank you.
Thank you, everybody. Have a good day.
Yeah, thanks everyone.